So even though we don't have class, we still have to continue on doing section 2.3, addition and subtraction of matrices. Sorry, I'm still coughing. In the previous section, we learned to use matrices as a tool to help us solve systems. But matrices can be useful in other ways as well. They can help you organize information. Anytime you've ever used a spreadsheet, you were really working with matrix. So, in this section, we'll discuss how you define the size of a matrix, what it means for matrices to be square, what it means for matrices to be equivalent, and how to add and how to subtract matrices. So with that said, a matrix is essentially a spreadsheet. It contains columns and rows and is used to store information. Matrices are usually named with capital letters like A, B, and C. We talked about this before. The size of a matrix is defined as the number of rows by the number of columns. A matrix with m rows and n columns is called an m by n matrix. So in this first example, matrix A has 1, 2, 3 rows, 1, 2, 3 rows, and 1, 2, 3, 4 columns, so that's a 3 by 4 matrix. Matrix B has 1, 2, 3, 4 rows and only 2 columns. So this is a 4 by 2 matrix. And again, columns go up and down like columns or pillars of some sort, and rows go left to right. A matrix with the same number of rows as columns is called a square matrix. Moving on to the next page and zooming in. This matrix is an example of a square matrix. It has 3 rows, left to right, 1, 2, 3. I'm not saying that quite correctly. This is, row 1. This is, oh God, what just happened? On page 3 somehow. This is row 2, and this is row 3. So it's got 3 rows and 1, 2, 3 columns, so this is a 3 by 3 square matrix. Now I'll talk about matrix equality. 2 matrices are equal if they have the same size and if corresponding elements in the matrix are equal. So for example, what values of x, y, and z make the matrices equal? So first you have to check that they are the same size. Are they the same size? Yes, they are. They are both 2 by 2 matrices. Then you have to set corresponding entries equal to one another. So this 1 has to be equal to this x minus 1. This negative 3 has to be equal to this y because they're corresponding entries. This 4 must be equal to 2z. And luckily for us, this 2 already equals this 2, so we don't have to do anything to that. So back to the first equation. If 1 equals x minus 1, solving that for x by adding 1 to both sides, you get that x is equal to 2. Negative 3 is equal to y is already solved for y. And then in 4 equals 2z, we would simply divide both sides by 2 and get that z is 2. So now moving on to adding matrices, which is very, very simple. The first thing you need to know about adding matrices is that you can only add matrices if they are the same size. I'll need more space for that. So you have to always check that your matrices are the same size. The second thing you need to know is that to add matrices of equal size, you simply add the corresponding entries together. So for example, look at this problem, matrix 1, 0, negative 8, 4, 5, 3, plus the matrix with entries negative 4, 7, 6, 1, 1, and positive 6. What is the size of your two matrices? This first matrix has 2 rows and 3 columns. The second matrix also has 2 rows and 3 columns, so they can be added together. To actually do the addition, you add corresponding entries. So in row 1, column 1, you have a 1 in the first matrix. In row 1, column 1, in the second matrix, you have negative 4. Then you take 0 plus 7. So they're essentially in the same location in their individual matrix. And then negative 8 plus 6, 4 plus 1, 5 plus negative 1, and 3 plus 6. Simplifying that, you just get 1 plus negative 4, which is negative 3, 4 plus 1, which is 5, 0 plus 7, which is 7, 5 plus negative 1, which is 4, negative 8 plus 6, which is negative 2, and 3 plus 6, which is 9. Final page of notes. So for this example, what do you think is happening here? Do you remember the first thing I told you needed to always check? The first thing you always need to check is if the two matrices are exactly the same size and shape. This first matrix has how many rows and how many columns? This has 2 rows, can't get the X, and 3 columns. But this second matrix has 3 rows and 2 columns. So they are not the same size matrix at all. So when you encounter two matrices of different sizes and you try to add them, you simply say it can't be done. You can only add matrices that are exactly the same size. So a little bit more information about matrices before we start talking about subtracting matrices. We first should define an additive inverse. The additive inverse of a matrix, or its opposite, of matrix X is matrix negative X, in which each element is the additive inverse, and again, additive inverse means opposite, of the corresponding elements of X. So for example, matrix 1, 0, negative 8, 4, 5, 3 has additive inverse, where each entry's opposite is put in here. The opposite of 1 is negative 1. The opposite of 0 is still 0. The opposite of negative 8 is positive 8. The opposite of 4 is negative 4. The opposite of 5 is negative 5. The opposite of 3 is negative 3. Another thing you should be aware of is something called the zero matrix, and it's written as the letter O. So this is actually the letter O. It's an M by N zero matrix with all zeros as its entries. Matrix O is the additive identity of any M by N matrix, which simply means if you take any matrix, we'll call it matrix A, and add to it matrix O, which is the matrix of all zeros, you get matrix A back. We needed a little bit of that information to be able to talk about subtracting matrices. To subtract one matrix from another, first, again, any idea what you have to check first? You should first check the matrices are the same size. Then, just like adding, you subtract corresponding entries. So, some examples. The first matrix is a 2 by 2, and the second matrix is also a 2 by 2, which means you can subtract them. You will do 1 minus negative 5, it's a double negative there, 3 minus 1, negative 7 minus 9, and 8 minus 7. Simplifying that, you will get 1 minus negative 5 is 6, 3 minus 1 is 2, negative 7 minus 9 is negative 16, 8 minus 7 is 1. This next two matrices, the first matrix here is a 2 by 2. I don't know why I can't get my beginning of the number 2 to right. And the second matrix is a 3 by 3. What do you think about that? Hopefully you thought it can't be done. Why not? Because they are not the same size matrix.